Algebra 2! Lesson 1-6, stretch functions! We were talking about some review from yesterday 1-5. Yeah, yesterday 1-5, we were just translating functions. We were shifting them. So now we have a bigger formula. Look at this guy. Our general equation is gigantic. It's a times all this stuff. There's a b in here now. We had h and v. Those look familiar. But a and b are our new letters. What the heck are those guys doing? We will figure that out. And we already knew this from last time. V and h, they shift the function up, down, and left and right. We knew that from the warm-up today, which was talking about this. The answer here was right 3, up 4. So we know we're basically masters at translating functions right now. We're going to play with Desmos some more. So, laptops open.
Oh no, I'm out of my charger again.
Laptops open. Oops, that's great. Shouldn't record that. Laptops open. Desmos.com. Go and start your graphing. All right, we are going to graph two functions. The two functions that we will graph are y equals a times the quantity of square root bx. Hint, hint, you can type in a square root, that square root function, by typing sqrt, and it will pop up with the square root. So if I type in y equals sqrt, see, as soon as I hit the t button, boom, turns into the square root. So square root, oh, I need a bx, and I need an a on the outside. I also need a y is equal to just the normal square root of x.
We're typing in those? Wait, how do you add the square root?
SQRT, if you just type in those letters, it'll automatically pop into a square root. Alternatively, if you don't like typing, you can click on this thing, this keyboard, and then it has square roots somewhere in here, I'm sure. Functions, anything. That's an nth root. Am I missing the square root? Oh, there it is. There's a square root. I can add square roots a bunch of times.
When did you put your sliders?
My sliders are A and B. They're both at 1. So everyone has this. Nod your heads yes or no. Okay, we'll wait for Gio. And I want to make sure I'm in projector mode so that you guys can actually see what's going up on the screen. Also, if you want to change this colors, you can come up here to the gear in the top left-ish area, top right of the editing screen. And you can click on these to change the colors if you think that they're both the same color. Obviously, if they were both, I don't know which one of these is purple and which one is blue, but if one of them is one and one is the other, I can't tell the difference, but blue and red, I can definitely tell the difference. All right, so Gio's there, nod his head.
Yeah.
Okay, so what I want you to do now is drag around A and B, and just notice what happens. When I drag around A, oh, look what it transforms the original function by doing something. Oh, when I drag B, it does something. Oh, whoa, look at that. That's cool. So I want you to play with it and just write down a few observations. It doesn't have to be about just A. It doesn't have to be just about B. I want as many observations as you can cram in these 3 lines. Go ahead and do that now. And we're back. So one thing that I did make a note on was that we changed these intervals. So if I click on the number, you can change what it goes between. I also did something extra without telling you guys. I changed the step by 0.05 just to make it so that when I come back here, it locks on to every 0.05. I don't have any like 0.1s, which makes it a lot easier for this to come back to 1 just by dragging it. All right, so when I change A, what were the observations when I change A? And for those of you watching, I just clicked the play button over here on the left-hand side. What happened when you changed A? What were your observations? Specifically about A. Do you have anything about A? Gio, go for it.
So A moves the line up and down in the y-axis.
Yeah, A, and I'm gonna, moves function up and down. And I want to be careful about using this word moves. So I think I understand what you're saying. It changes it in terms of the up and down. But in terms of moving it, it doesn't really quite move it. With the word move, it's not a translation. Because if it was a translation, it would be shifting it up 1, up 2, up 3. That's moving it up. But it was really kind of scaling it up with keeping the vertex at the same point, though. So I'm going to come back here and just kind of edit yours a little bit. I'm going to say A stretches. Stretches the function up and down. Cool. What about B? What did B do? What happened when you moved b? So let's come back over the graph. So if I come back to my parent function by bringing this back to 1 and I let b play out, what did b do? Can someone explain what was happening with b? Stego, go for it.
It like shifted. I don't know how to explain it. Like when it was on the, it was like diagonal.
Diagonal, okay. Hey, I bet I can help you with this too. Let me try graphing a different function. Instead of doing a square root function, let me try, and maybe I should turn this music off while I'm doing this. Let me try this function. Look what happens when I move b on this function. It was a little bit harder graph, that's why I didn't have you do this on your notes. But when you move a, it's pretty clear that it squishes it up and down like Gio said. But what happens when I move b? It stretches it again, but in what direction?
Left and right.
Yeah.
It gets fatter and A gets skinnier.
Yeah, and then you can kind of relate it to what was happening over here. When b was moving, it was trying to stretch it fatter and skinnier in terms of the x direction. So how do you want to phrase that, Stego, to get your xp? You probably want to use the word stretch, and then something goes over here. B stretches.
B stretches function left and right.
Oh, function left and right.
Is that right?
Yeah, I like that. Function left and right. All right. Any other cool things that you noticed? Maybe about stuff flipping over? Because one of them allowed it to flip over a certain axis, but not the other. And then the other let it flip over a different axis, and again, not the other one. Did you notice that? What's a good way of saying one of those things or both of them? Yeah, Fiona. Or just any observation that you have at all.
B, let's say B doesn't let it go negative on the y-axis.
Ah, so B, so changing B doesn't affect top/bottom, if it's on the top or if it's on the bottom. Is that what you're trying to say, or is it the reverse of what I'm trying to say? So you're saying
This one, it's just like it never goes on the bottom.
it never goes on the bottom. When I change B, I can still never go on the bottom. I can't have this reflection over the x-axis. Again, this is your x-axis. You can't reflect over that. You're only allowed to reflect over which axis? The y-axis. Yeah, you can only reflect over the y-axis. But if I come back and I set this back to 1, and I change A though, A does allow you to go over that x-axis, but it now never allows you to go over which axis? The y. Yeah, that's pretty cool. I'm glad that we saw that. All right, I ran out of room. I wish I had one more line. I'll make a note to myself. One more line for next year's notes. Stretching functions. Okay, so let's come back. We're ready to start following down with Mr. Sindell's notes. When A is larger than 1, so I'm coming back here. When A is larger than 1, in fact, I'm going to probably use this graph from now on because it's a little bit easier. So here I am at 1, but when I'm larger than 1, it's stretching it in this vertical direction. So when A is larger than 1, it's a vertical, yeah, there it is, stretch. And I realize I've not been rewarding anyone with XP. I need to come back. Let's come back here to Algebra 2. All right, I know that Stego, you did it twice, right?
Did it.
Just once? And then Gio, you
No,
did it?
she did it twice.
Okay, I thought it was twice. And then Gio, did you do it once?
Yeah, I know I did 3 times.
Anyone else that I forgot? I think everyone did thumbs, right? Oh wait, I need to make sure that this person is not currently here, this person is not currently here. So all 3 of these people, you should be watching the video, and if you're not, then that's not good. But you don't know that you're not in here because you're not watching the video, so kind of like problematic. 10 XP procedure, cool. Yeah, so it's a vertical stretch. So I want you to kind of do this symbol over here. It's a vertical stretch, so it pulls it this way. Vertical, if you didn't know, is up and down. So vertical stretch. When A is between 0 and 1. So let's look back at Mr. Sindell's graph. Between 0 and 1. So now I'm going to change A so it's between 0 and 1. There's a number between 0 and 1. Oh, look what happened. How would you describe what's happening? What is the red function doing compared to the blue function between 0 and 1? all these values. What's happening? How would you describe that? You can shout it out if you think you have an idea.
Horizontal stretch.
Close, because horizontal stretch would be more like changing B a little bit, because that's changing it in the horizontal direction. But I'm going to still reward you with XP. It is some sort of stretch, because that's what all of today is about, some sort of stretching. But what type of stretch?
Can you do it again?
Yeah, so let's come back to the graph. So between the values of 0 and 1, so all of these values right here, how is it changing from the blue graph? The blue graph was up here, but now it's all the way down here. It was down here, now it's all the way up here. How would you describe that? Some sort of stretch, or maybe a compress? That would be the opposite of stretch, would be to compress. To compress your tin foil into a little cube because you're done using the tin foil for your pizza or something like that.
Yeah, it is compressing.
Compressing in which direction?
Vertical.
Yeah. Vertical compression. I'm going to call it that way. And then this is what your arrows are going to look like. Vertical, again, is up and down, but now it's squishing it. If you don't like compression, maybe you can use the word squish, although I feel like it's less mathematical. S-Q-U-I-S-H, like squid, but squish, squish. Or Squidward, I guess, is I see that word in there too. Yeah, let me come back over here. I think that Geo and D3 deserve, oh, that's Andrea, Geo and Stego, you guys can get your correct XP. You both had part of the answer. All right, so that was dealing with A, and I have a third thing that can happen. When A is negative, so let's look over here. When A is negative, so all of a sudden I'm positive and you're just stretching and compressing, all of a sudden it's negative. Whoa, what just happened? It was over here, and now it's negative. In fact, this one is probably easier to see with this graph. When A is negative, it was up here. When it's negative, it's down here. How would you describe that? Quiet raised hand. How would you describe that in your own words, Fiona?
When A is negative, Y is negative.
That's really good, but there's a problem with your definition, and I want you to fix it here. This is what happens if my function was originally a negative. What if this was originally a negative? So now my original function is that bottom one. Well, now all my values are on the flip side. So how can you alter your definition? Because it was down here, and you said, well, just make them negative. Well, they already were negative. So how are you going to fix that? And you can let someone else fix it. I'm going to still give you your 50 XP because you have the... You're going to let someone else do it? Okay, you can call on someone else.
Yeah.
It reflects it.
Yeah, there we go. So when A is negative, it reflects over what, Geo? The X or the Y axis?
Just the X.
Over the X axis, yeah, very nice. So Geo and Fiona, I will give you to the
Yes, Geo,
XP.
Fiona.
Geo, Fiona, give you guys the XP. I still see a hand. Yeah, what's up, Steph?
Ooh, I'm gonna write you.
Oh, sorry. I just saw the hand in the corner of my eye. I just assumed it was a hand even when I looked at it. Reflects over the x-axis. So for this picture, go ahead and draw the x-axis and do like a little loop or loop. It can go either or over the x-axis. I like just having a picture because sometimes we forget what the x-axis without thinking for it for a few seconds. Cool. All right, so now let's take a look at B. There's three things that can happen. It's the same three conditions. So let's come back over here to our quadratic graph. So now A is constant. A is still 1. What happens, and I'm going to make both of these positive again, undoing my example. So what happens when B is bigger than 1? It goes up there. What happens when B is bigger than 1 on this graph? Set it back to 1, Mr. Sindel. In fact, this is really annoying. I'm going to change these bounds really quick. Sorry. 2, step by 0.05, tab, tab, tab. This is going to be -2 to 2.05. All right. So now that this is back here at 1, it's a lot easier to drag this now. What happens when B is bigger than 1? Whoa, what happened there?
It stretches horizontally.
Are you okay, Eva?
I'm better.
Better? Some ice helps. We have notes for you right here. And you can join the mega group if you would like.
I'm just crying. Like,
Finally.
But I don't think I'll click.
yeah.
I'm gonna
Yeah. All right.
Are you still? She's still coming. Yeah, of course.
Sorry, I was just.
Yeah. So coming back here, I don't want to take away from the significance of that. I'm sorry that you got hurt of it. And was it your writing hand?
Yeah.
Are you gonna be like Chris and you have to write left-handed now? Okay. Let's see how it goes. And everyone that wants to join her in the spirit, like Fiona is going to join her in the spirit of writing left-handed, obviously. Yeah. So let's look at what happens with B. When B is bigger than 1, so here it was at 1, and I'm going to drag B bigger than 1. What do you notice? Is it being compressed or stretched, and in which direction? Let's give it to Stego.
Okay, it's a horizontal compression.
It is a horizontal compression.
Don't push it. I'm not gonna. Oh yeah.
Horizontal compression, which is weird, right? Because up here we had a number that was bigger than 1 and it stretched it. Now we have a number bigger than 1 and it compresses it. And here is the relation to yesterday's notes. Are you guys ready for this?
Yes.
Look at this. Notice where it was in the function. B was inside the parentheses. H was also inside the parentheses. And yesterday in the notes we said everything inside the parentheses is backwards. What? Whoa! I know, it's crazy. Everything inside the parentheses is backwards. Well, now B, we're dealing with B. B is inside the parentheses. So when we have a number bigger than... Oh, wait, sorry. Yeah, when B is bigger than 1, this should say a B right here, but no one caught it. You can catch it next time. There is another one that I'm not going to catch, but I see it already. Anyone want to try to catch it? Go for it, Stego.
The B on the when B is between.
Yep.
Whoa.
So log in your extra credit tracker.
Yeah.
So when B is bigger than 1, it's a horizontal compression. It's the reverse of what we think it is. It's backwards. Weird, right? Backwards, because it's inside the parentheses. So remember this for the rest of your mathematical career in high school and college and whenever you take math. Inside the parentheses, in terms of a function getting changed, inside the parentheses is always backwards. Backwards from whatever you thought. That's a horizontal compression. Okay. Now between 0 and 1, let's go ahead and take a look at our graph. So it was here at 1. I'm going to change this red function to be between 0 and 1. What would you call this thing between 0 and 1? We'll give it to Fiona.
Horizontal stretching.
Horizontal stretching. There it is.
Stretch.
I'll give it to her. And let me come back over here. Give Stego your XP. Give Fiona your XP. Perfect. We're almost done. Almost done with the front side. When B is negative. When B is negative. This one is easier to see on this graph. On the graph of the square root function. So here B was at 1. Oh, almost. Here it was at 1. Now this red function is going to be negative 1. Sound effects. What do you notice? What happened? Use Gio's word reflect. And Gio might use his own word reflect. We'll see. I'm going to give this one to whoever has the lowest XP because everyone has been participating so much. Who is the lowest? Who needs it? Andrea needs it the most. Next is Stego. Go for it, Stego.
It reflects over the y-axis.
There it is. Y-axis. Andrea's getting tons of XP right now, getting Eva caught up, so thank you, Andrea. And draw a picture for all of these. Let's come back to all three of these. Horizontal compression is squishing it this way. Compressing it this way. Stretching it is pulling it out this way. Pulling it in that horizontal direction, in that X direction. What's up, Fiona?
Are we only gonna have to graph these?
You will not have to graph them, but you need to understand how the graph is affected. A lot of these are just going to be multiple choice for the quiz and the test. But I shouldn't say you never have to graph them, because you will, but not for a little bit. And when we do, I'll give us the notes for that. All right, so reflects over the y-axis. Go ahead and draw a line for the y-axis, and whoop, it flips over like that. Whoop. All right, everyone has those three pictures for B.
Yeah.
I don't see any other pencils writing, so I assume you have all three of those pictures. And we're going on to the back. All right, our new and improved compressed rule. Are you ready for this? Here we go. A. This will stretch it. So stretch, we did this picture. G, again, just like yesterday, this G of parentheses is just a fancy way of saying any function. This could be an absolute value instead of a G. It could be something quantity squared. It could be something cubed. It could be a fraction. I don't know what the function is. This is a general way of saying any function. All right, B. This was stretching it on the horizontal. And H, we already know what H does. Was that left and right or up and down? Left and right. Okay. So instead of doing arrows that are disconnected, we're just going to go arrows that are connected. That's the main difference. Stretching has arrows that aren't connected, as if I'm pulling it with two hands, just ripping it apart. And then H is sliding it. And then V again, that's going to be up and down. A solid connected arrow. And now the key part here is that everything inside the parentheses is the opposite. Everything here is the opposite. This H and this B are the opposite way that we would normally expect them. Normally when you have a big number for B, you would expect it to be stretched. But it's the opposite because it's inside the parentheses, so it's going to be a compress. And then this is going to be normal for the A, and this is going to be normal, normal for the V. That's our nice compressed rule. If I had a 3x5 index card, if I had that, I would be almost ready for half the material that would be on the test, just with this condensed rule alone. All right, let's try out some fancy examples. Try out our new tools. All right, I need a reader. Go for it, Fiona.
G is a transformation of F. The graph below shows F is a solid blue line and G is a dotted line. What is the formula in G in terms of?
Perfect. So let me give you your XP before I forget. Yeah, so we start with F. We start with this blue solid line. And then we are going to transform it into this red dashed line. So which of these is it? We know that it's going to be either compressed or stretched in the horizontal or vertical direction. You have to figure out which one it is. And then once you do that, you have to come back to your little cheat sheet and figure out what value that variable should be. So think about it. I want you to spend like a good at least 15 seconds thinking about what's happening here. We have 6 things that can happen. You can have a vertical stretch. You can have a vertical compression. You can have a reflection over the x-axis. You can have a horizontal compression. You can have a horizontal stretch or a reflection over the y-axis. Sometimes in the future, I will be doing multiple of these. But for now, it's just one of them. Which one is it out of those 6? So you've been thinking, you've been thinking, you've been thinking. Now share with someone around you. Did they get the same answer as you? Share with people around you. All right. Do we want to do a quiet raise hand? Are we confident enough in our abilities? You gonna go for it, Gio? Go for it.
I got C.
You got C. Okay, so I'll go ahead and bubble it in for you. But I also want to know what type of thing is happening here. Out of those 6 things, those 6 words, horizontal stretch, reflection over y-axis, out of these 6 things, what happened from blue to get to the red dashed line?
Horizontal stretch.
Horizontal, it wasn't a stretch.
I mean,
It was a compression because it got smaller, right? It was as if I took this blue function and I squished it. You want to change your answer? Okay, that's fine.
It's
Oops, I was choosing the wrong thing there. I need to use the erase tool. All right, I'm still going to give you, because you were able, you're able to give me, I'm just going to go like this. You're able to answer some of that. It is a horizontal compression. Because it's a horizontal compression, is it A, B, or C? Fiona?
Wait. I take that back.
Okay. Go for it, Gio, again.
It's A because you're compressing it.
It's A, you're compressing it. It's inside, so it's the opposite. Usually you would think, oh, compressing, I need a small number. I need like a fraction number. I need like 1/2. But no, it's not. It's just a bigger number. It's opposite because it's inside the parentheses. The correct answer is indeed A. Yeah, Fiona.
So if it were stretching it, how would we know if it's like 2 or 1 half?
If it was stretching it, so stretching on the inside of the parentheses needs to be a 1/2. If it was a negative, though, that's flipping it over an axis. Yeah, so both of those can be affected. So this one is doing 2 operations at once. It's reflecting it over the y-axis, and it's also compressing it. All right. So go ahead and write in your notes, this function right here is a horizontal compression. I don't know why I said compressing. Compression. Okay. All right. Ask me questions again about example 2. Otherwise, we're going to go to our final example, example 2. You know what I mean. Ask me questions about example 1. Sorry. Example 1 questions. Questions. Get your questions right here.
I'll have my question after.
All right. Sounds good. Example 2 then. Another beautiful reader. Andrea, go for it.
G is a transformation of f. The graph below shows f as a solid blue line and G as a dotted red. What is the formula of G in terms of f?
Very nice. Okay, just making sure that I don't forget to do your XP and make sure that Eva is back so you can start participating. Yeah, so we have, again, F, and then G happens after we do stuff to it. So what is happening? What of those 6 things, maybe a few of them at once, is happening? Gio has an idea. Stego has an idea. Fiona has an idea. Eva, are you caught up enough to where you think you could answer this one?
Nope.
Nope, okay. Stego.
Okay, I'm not sure that I'm right.
That's
I'm
okay.
really confused. But is it a vertical stretch?
Vertical stretch. We'll do thumbs for this one. She's saying a vertical stretch.
That was horrible.
Thumbs up or thumbs down? Gio says some thumbs down, Andrea thumbs up, Fiona thumbs up, Fiona in the middle. Uh-oh, that's pretty balanced. Oh, sorry, Fiona's thumbs up. But that kind of averages out to a thumbs in the middle, which means we're still not very sure. All right, so again, if I had this point right here, if I stretch it stretch it away from this x-axis. It's being stretched away, so it is indeed a vertical stretch. This point was stretched away from the x-axis, so it is a vertical stretch. You always stretch away from the axis. So this is indeed a vertical stretch, and I realize that my handwriting could have been better there, so I'm going to rewrite this. This is a vertical stretch. Well said, Sego. And then from there, which equation is it? Is it A, B, or C? Gio has an idea. I want more hands, more hands. Is it A, B, or C? Math is not about speed. Really think about what's happening here. It's a vertical stretch, so you come back up here. Vertical stretch, that was this one. It's when A is bigger than 1. A goes into this formula. A is there. It has to be bigger than 1. Therefore, Eva, yeah.
A.
It is indeed A. Very nice. It is A because it has to be on the outside, and a stretch needs to be a number bigger than 1. Everyone got XP today. Very nice. Oh, it's still 50 XP. I hit the wrong one. All right. Are there questions? Questions? No questions? All right. Go ahead and write your summaries.